Good afternoon, everyone. My name is Josephine Watson, and I'm the Commercial Project Editor here at iGaming Business. Today, we're happy to be hosting a webinar for Akamai Technologies, which will be discussing real user and performance monitoring. This interactive section will explain the best practices for operators and platform providers when considering how to monitor and tune the performance and quality of modern HTML5 games at scale. We'll be looking at solutions beyond the typical network and CDN-related timers, as well as new key metrics and insights that operators and platform providers could be seeing from their users in real time. Your host for today will be Tim Verecki, Web Performance Architect, EMEA, Akamai Technologies. There'll be a question and answer section following the presentation, so please do submit any questions as we go along, and we'll try to address as many as possible in the allocated time. With that, I'll hand over to Tim.
Thank you very much. Good afternoon, everybody. So I'm Tim, and in the next, let's say 30-45 minutes, I will talk to you about best practices on how to monitor and tune modern HTML5 games. Now, instead of boring you to death with PowerPoints, I'll show you how some of our other customers do based on some, let's say, some demo data, but that will give you a nice impression of what the current limitations are and what the possibilities you might have in the future. So let me switch to the demo mode. Oops, escape. So it doesn't matter if you're basically an operator or platform provider. If you look at many of the HTML5 games on the web, so when you can search for casinos, you see you have plenty of possibilities to play games. Here, more than 1,500 games, and here you see even more games. And I'm based in Belgium, so I tried one of these, and in the end is all of these games have something in common. When you start up, you see a splash screen. Next, you're basically in the lobby. Some of them, you get an intro video, and then you can actually start playing. And what you'll see is that what you typically did in the past is many of you have a CDN or a multi-CDN approach, and you do track the performance of the individual objects. And you want to make sure that your CDN is as fast as possible everywhere in the world, and that's great. However, if you look at the performance of the game itself, network is one aspect, but in the end, JavaScript and the perceived performance by the end users is also very important. And that's basically what I'll explain how you can do that. So with real user monitoring. So what do you need to know about real user monitoring is there you look actually at the performance of your real end users. So it's not fake synthetic test, let's say from a data center somewhere in the world simulating a user. It's really your end users with their operating systems on their browsers in their countries under their network conditions, how they play your games and how they see the perceived performance of the games. So it's real users. So if they have Wi-Fi connection, they'll probably have a better, let's say, better experience than when they have a 2G or a 3G connection. So it's really, let's say, really end user perspective. Now, what you see here is data comes in real time. So you have real time visibility on the performance of all your games. Doesn't matter where people are in the world. So typically within 3 to 4 seconds, if a user plays a game, you can actually see the performance of that data. What data do we collect? So here you see the typical, let's say that this is the typical network related things. So front-end time, back-end time, SSL handshake time, and then page load. However, for many games, page load as we know it from websites does not really matter because a huge amount of the activities are actually done after the page load. So for many HTML5 games, you'll see that the page load is actually super fast, but that the user can only start playing maybe after 4 seconds, 5 seconds, 6 seconds. So therefore, we have what we call perceived performance. So that's how does the user perceive the performance of the game. And one of the first things is, for example, first paint. When was the first time I saw, for example, the splash screen? That's great, but it's not necessarily, it gives the first feedback, but it doesn't mean he can start playing the game. visually ready is an indication when the full, let's say, when the game seems to be ready to load. And then, of course, there is JavaScript. So we have things like time to interactive. When was the user actually able to interact with the game? On top of that, for one of our large gaming providers in Europe, they also added some custom timers. So they added a custom timer. What was the time to splash screen? What is the time to game loaded? So all their games, when the game is loaded, they fire a certain, let's say, Ajax request. They track that Ajax request, and they know when we see this request that the game is loaded, and they track the performance of all their games based on these conditions. So data comes in real time, and we don't do any sampling. So every single interaction, that can be the initial game load itself, as well as, for example, interactions inside the game. I suppose I want to upgrade my budget, or I play, or you have some backend communications with the backend server for credits or validations of the credits. These all have impact on the gameplay as well. So we can also track the performance of these additional requests. So it's not just about the initial load, it's also the continuous load. Now, I said we don't do any sampling. Why is this important? Is in the end, you want to validate the performance of all the different games. And you'll see, for example, here that if you just look at the operating systems, that the performance can really differ. For example, here you see Android OS is slower than Windows. And so as we track a huge amount of data, we don't do sampling. We can actually zoom in on the individual sub-levels and still have enough meaningful data to make informed decisions. So you have plenty, I will not show them all, but you have like plenty of dimensions. So of course, countries, browsers, browser families, operating systems, device types, even device manufacturers, connectivity types, and many of our, one of my existing customers here in Europe, they also added some custom dimension. For example, the same game loads on different casino websites. So they added the casino website as another dimension just to validate if the performance of their games on the different casino websites, if there is, for example, a correlation between the two. So these are all things which we can do. So things to remember: real time, a huge amount of data. So what do we capture? Is for every single request. So here you see now the performance of somebody in San Salvador using a dial-up connection, and then now this is an example of a website, but this would be the same for a game. You see that he's using an Android tablet using Chrome, and here you see all, let's say, the initial game request, and then potentially all the individual resources like fonts, audio, video, JPEGs, but also third-party, let's say even third-party tools can be extracted. What kind of data do we get? Well, a huge amount of data, there are more than 40 of them, and you can also add some custom, let's say some custom timers to validate the performance. For example, one of the gaming providers I work for is all their games have like a JSON config file, and that's like key. That delivering that file is really key, and I want to track the performance, so that we created a custom timer to track the performance of the user going to the game and the time it takes to get that config file, including all the other overheads, and I use that as a metric as well. It's not just about performance, but also things like page, let's say the amount of requests, page construction, so you can validate how is our game load on a, let's say, Retina display with much better images compared to the same game on a low-end device. If your CDN supports server timing, we can also actually see things like if it was a cache hit, cache miss, etc. What is nice here, you see the network heat map. So that's typically what you cover in probably today's monitoring tools you have. But they also here in pink, you see the JavaScript performance. So you can actually see when JavaScript was actually running. And we have a concept what is called long tasks. Those are JavaScript functions which take more than 50 milliseconds. And if it takes more than 50 milliseconds, a function can really impact the, let's say, the perceived performance by the end user. And it means, for example, if they click and at that point in time, another JavaScript function is running for 200 milliseconds, it means you need to wait for 200 milliseconds before that click is actually captured, and that can impact the user performance. So this is real users. So key thing to remember is real users, no fake traffic, and all data is collected. Now, you might ask yourself, like, why should you care about performance in games? So there are plenty of studies on the web which say, oh, web performance is key, web performance is key, web performance is key. But a valid question might be, what is the impact of performance for us? Do people stay longer? Do they play longer? Do they actually play more? Those are the questions you can ask, and that's one of the advantages of mPulse. It's not just a tool which tracks the performance. The second question it allows you to answer is, why does performance matter for my games? And does it actually matter? So what you see here is, so next to the performance metrics, we track things like completed sessions, bounce rate, so that's a user playing a game and let's say not going to a game and straight away going away, how long they actually play games and how many games they actually played, or how many interactions they did inside the game. And then we can also let's say track, for example, revenue either from ads or from let's say from another type of metric. Now, what you see here is, and this is, you'll see this if you enable this on your games, you see something like this. So the blue bar shows the performance distribution. So you see a huge amount of users here has a load time between 1 second and 2 seconds, which seems good. But a fair amount of users goes towards 3 seconds, 4 seconds, and then you have like the typical long tail with 5 seconds, 6 seconds, 7 seconds, 8 seconds, and longer. The question is, should we care or should you care? What the green bar shows, as the green line shows, is the bounce rate. So this is a user coming, let's say, playing a game and straight away going to a game and straight away going away. That's of course not what you want. You want them to play as long as possible and as much as possible. So what you see here, that if the performance is good, that the bounce rate, so the amount of people straight away going away, is lower than when the performance is bad. So what does it mean from a business perspective? If I can move the users here, which have a 7-8 seconds, let's say, performance, if I move them to the left-hand side, then they'll play more. So this is now for a website, but we did the same exercise for a large gaming customer in Europe, and they saw similar things. Like if we show them that if performance is better, it has an impact on their key KPIs, which was how many, let's say, how many interactions internally in the game and how many actually games they played. Now, my story is like, if you're a bit critical to what I'm saying, my story is correct. So if the performance gets better, the bounce rate is lower. Now, what you see here is, if the performance is like super fast, then the bounce rate is very, very bad. Now, I'm not saying that you need to slow down your games, but when does a game typically load very fast is if you have, for example, a JavaScript error in a browser version X, and therefore it doesn't load all the additional content. It means the page loads super fast, but the user can't play. And so that's like a bad user experience. If under certain conditions you get, let's say, a page not found or an old game, and you measure it, those pages are typically super fast, but end user experience is bad. And so this graph tells me two things. Users here should go to the left, and we should find a way to find, for example, certain JavaScript errors under certain browsers, certain conditions, etc. And that's what I'll show now, how to find ways to improve the performance of your HTML5 games. So we know how fast we are. We know actually that performance now matters for our games. The next thing is where to start. And one of the key things there is what I've seen a lot is that you can tune a lot on performance, make things better, but still don't see a business impact. And one of the values of Amples is, as we track a huge amount of data in a GDPR friendly way, of course, if we track a huge amount of data, and we have some smart algorithms, and one of these is the activity impact score. What this will allow you to do is, here the green bars will tell you, for example, for the different games. You have, let's say, a portfolio of 100 or 1,000 games. You'll see the most used ones, and then the green bar shows the performance of that game. So here, this one is super slow, this one is slow, this one is slow, this one is actually fast. Now, what does the blue bar tell you? It tells you what is actually the impact of bad performance on the activity of a user. So the bigger the bar, the bigger performance impacts the end user. The lower the bar, the lower the impact of performance. So what does it mean? Is here you see, for example, let's say this is game X and it's slow, but the impact of performance, making it a little bit faster and a little bit longer, we have seen that that doesn't have a huge impact on the activity. While for this game, although it's much faster, the impact of performance is huge on the amount of activity. So from that perspective, if you want to make more money or if you want to have users play more, it's better to make this game 100 milliseconds faster, because the impact will be much bigger than making this game, which is slow, making 2 seconds, 3 seconds faster. So that's the first thing we can help. We can help identifying where to prioritize first, so you don't spend the time optimizing the wrong games. Or for example, in this case, I would rather make some improvements to the gameplay or fix some bugs rather than working on performance. Here, I would rather focus on performance first. So that's the first thing. Now, the second thing is, okay, now that we know the priority, how do we now tune for performance? So we collect a huge amount of data. You saw these waterfalls before. We, of course, don't expect you to, let's say, look waterfall by waterfall. We have some nice dashboards which will help you identify certain performance bottlenecks. So what you see here is a performance tree map, and the bigger the bar, so the color indicates performance. So green is good, red is bad, standard, and then the size of the box explains you how many requests we saw. So for example, here you see desktop green, mobile is not as fast. So let's zoom in, drill down. So here you can, for example, see that on mobile, you could, for example, see that this game is red while this game is green. And let's validate why this game is red. We click on it. We see straight away that it's not a browser specific issue. So on Chrome Mobile and on all the others, it seems to be red. Even if, let's zoom in further, and it's also not country related, although some countries seem to be green. In general, we see that it's red. So that's a first indication. Now, once you identified a certain game, what can contribute to the game performance is, for example, individual resources. So let's now look at a similar thing, but now looking at resources. So here everything seems green, but Amples also allows you to set up some performance budgets. And so here I say that the limit for green is 1.5 seconds, which was a bit high. So let's set our performance budget to 500 milliseconds. And we straight away see that for this game or this website, everything seems to be green except for the same. For example, for the images, if you click on it, you can actually see the sorry, let me move the path. You can actually see the path of all the images. Certain of them are small, certain of them are fast. So that's another thing. So you can look at individual resources. And here you could, for example, identify a third-party tool, or let's say a third-party font which is slow, and then moving that font to an internal, let's say to your internal CDN, might make it faster. That's one of the things we, for example, saw. Now, a resource, it's in the end, it's not because a resource is slow that it necessarily impacts the end user performance. So before you actually remove that data, we have what is called the resource impact analysis. Because removing a resource or spending time trying to reduce the size of it might be complex. So what you can see here is you can actually zoom in on certain, you'll be able to zoom in on certain games. And typically JavaScript is slow. So here you see the median load time is almost 500 milliseconds. Now, if I would remove this resource, what would be the impact on my page load? Or suppose I make this object a little bit slower. It's like, what would happen if the performance is getting worse or slower? You can actually easily simulate what would be the impact without actually having to do the development first. So that's another advantage. Next, it's not and this is, I think, key. It's not because a certain resource loads fast or loads slow that it actually impacts the end user. So what you see here is what we call the aggregate resource waterfall. You see this for your domains, but potentially all the third-party domains when the individual resources load. So let me actually zoom in on this one. Of course, you can filter on scripts and images and fonts, all these things. So if you look, for example, at the bottom, you see that here, let's say you see this icon medium. Although this icon medium might have a very slow performance, you see that it actually only loads after the initial page load. So making this one faster or slower would not have any impact on the, for example, the first page. While other resources, you might see that, hey, this CSS or this JavaScript or this image is actually hurting the initial rendering of the page because the size of it blocks other more important content. So this allows you to prioritize when certain resources are loaded or not. So this is to identify bottlenecks. That could be if you're a specific game developer and you can really zoom in on your game itself. If you're more, let's say, on the operations side and you want to look at all the games together, you can also have this view. And Impulse is not there. We are not just there to, let's say, really make performance better. Other things you can do is, for example, tracking performance budgets. So what is, let's say, after each deploy, each time when there is a new game, there is always the risk that, let's say, a new asset makes suddenly the game much slower or the initial size. So here you see, for example, for the top games, the top 12 of the games, you see the individual timings. So all the different timers we saw, you can easily, let's say, easily add them to the list. But it's not just about the timers. You can also track, for example, the game, let's say, how many bytes they're actually part of the bytes which are sent. So the amount of requests or the amount of bytes which are actually sent towards the end user. And you can also track that over time and set specific budgets or even create some alerts. So each time when you say, oh, whenever a game is shipped and it has more than, let's say, 2 megabytes of images, then you want to get an alert and you can actually be proactive and make sure that with each new deploy, the quality is there. So this was pure, let's say, performance focused. But you remember the graph I showed you with the relation between business metrics and performance. Let me actually repeat this game's metrics. So this was all about moving users to the left. Now how about JavaScript errors? And your game developers, you can test as much as you want. There is always the risk that under a certain browser condition with a certain plugin enabled, depending on cookie settings, privacy settings, ad blockers being present, there is always a risk that certain JavaScript errors are introduced. And these JavaScript errors could have zero impact, it could just be a warning, but could also, for example, completely make the game useless because if you click on a button, it doesn't work and you can't play. So next to the real user monitoring of the performance, we can also track the real user JavaScript errors. And how you could use that as a gaming, let's say if you're delivering HTML5 games, is you can track and validate if certain games, whenever they're released or whenever there is, for example, a new release of that game, you can validate under new app errors if no new JavaScript errors have been introduced. And this is not just about your control, because you know whenever when you deploy a new game, but it's also about if a new browser version, if Chrome releases a new browser version and your game of 1 year old has not changed, suddenly could start getting application errors. So this you can really track the health and the JavaScript health of your applications under real user conditions. So how do our customers use this or can use this is, for example, each time when there is a new deploy, you can send via an API, for example, an annotation saying game X has been deployed, game Y has been deployed. So whenever you look at the graphs, you see when it corresponds to the different releases. So whenever there is a new release, what our customers do is they basically zoom in on the game itself, which has been modified. And as long as new app errors stay 0, and new app errors means we haven't seen new errors appearing. And as soon as that goes up, you can straight away, for example, zoom in. Oh, is it a browser specific issue? Is it a generic issue? Is it on certain? Is it a platform issue, or is it a generic issue? If you click on this, you can actually zoom in to the error itself. And here you see, for example, there is a syntax error at a certain expression, and now this is a bad example, but in theory you should see if the function, if it's linked to a certain function, linked to a certain file, what the error exactly is. So you would also see, for example, the stack trace, but that allows you to straight away go to your developers and say, hey, we see an increase in JavaScript errors on Safari version whatever, and it's specifically on mobile, and it's in this game only. And then you can actually validate and test and make the quality of the games, make sure that the quality of the game is actually back on track without losing unhappy gamers. So from that perspective, a small summary. So real user monitoring, not just focusing on the network, but also the JavaScript performance, because that can really impact that can be really different based on the browser, based on the device. If you're using a high-end phone with a lot of CPU, then JavaScript performance might be neglectable. If you play the same game on a low-end device and on a good connection, then the network is super fast, but the game might still feel slow. So that's something we want to avoid, and we can help track. We can help tell you like if performance actually matters. For 20, let's say for 50 of your games, the performance might actually matter. For other games, it might not. So we help you identify those. We help you to prioritize and zoom in on performance as well as JavaScript errors. With that said, I think I'm done with what I wanted to say. So I don't know if there are any questions, or if something is not clear, then feel free to ask them in the chat. Let me actually see if there are some questions. So in the chat, you can ask questions, and feel free to ask them. I'm happy to help or to answer them.
Great, thanks so much for your presentation, Tim. Some really interesting insights there, and it's great to see how your guys' work comes together, really. As Tim said, we're moving on to the question and answer segment of our session, so please do continue to send in questions. We've got a couple here to kick things off. So someone's answer here, we have a multi-CDN strategy, and we currently test the performance of our CDNs based on real users. Could you confirm how your approach is different?
Yes. Yeah, so many of our customers, our gaming customers, they use a multi-CDN strategy, and what they typically do is based on real users. For example, yeah, there are some known tools out there which based on real users will track the performance of individual test objects. So whenever the user loads a game in their browser, the game loads itself, and then typically let's say that monitoring solution will validate, this user in Jakarta in Indonesia will now I will download a test object from 10 kilobytes, a test object of 50 kilobytes, and a test object of, let's say, 100 kilobytes, validate the performance, do that over 3 or 4 different CDNs, and then that tool will tell you, in Indonesia right now, CDN A is better than CDN B, and that allows to switch. So yes, it is real user monitoring, but there you're only looking at, I think the key difference is that you're only looking at individual objects and not the whole gameplay. So you can see network performance related issues, also from individual objects only, not how they behave as a whole. So one object could block another object in real time. So that's one thing. And the other thing is it only looks at network level performance, not at, let's say, at the browser limitations or the JavaScript fighting for resources because 5 other apps are fighting for the same resource. So I think that's the key difference. So although it's real users, so that monitoring is typically better than, let's say, synthetic tests where you're really doing fake. But in my view, for modern games, it's not sufficient because it only looks at the network level. What was the SSL connection time? How much milliseconds did it take for downloading that object? But it doesn't give you a good perceived performance of the total gameplay. I don't know if you. Yeah, I don't know if that answered the question. Otherwise, feel free to let me know.
I think it's sort of covered it quite well. I'm sure our audience will bite back if there's any further questions they have to ask on it. Could you elaborate a bit more on GDPR and collecting data and how that sort of functions into what you guys are doing?
Yes. So we are collecting a huge amount of data. No sampling, 100% real time. So the GDPR question always comes up. So it's a good question. So the first thing we can, in the end, we only track performance metrics. So we're not, we don't add, let's say, cookies or long-term cookies. We only care about, let's say, the performance on short-term. On top of that, we have some GDPR or privacy-friendly settings. So you can, for example, decide not to track IP addresses. You can even decide not to remove certain query strings from being tracked because they could, for example, contain the, let's say, the user ID of that user. So there are plenty of possibilities to track all that performance data without actually individually identifying users.
And then another question we've got here is there one particular timer you suggest for HTML5 games?
Oh, that's a good one. I would say I think for HTML5 games is I think first one particular no. I think which one is key is first paint. So when was the first time the user saw, let's say, that loading screen? That's the initial feedback for the game. Now, if that needs to be fast, however, if from there till the actual game starts, it takes too long, frustration will build up and people go away. So I think that initial splash screen should be there as soon as possible, just to say to the user, hey, we are there. And then I think it's what we did at other customers is if, for example, when did the intro video start playing? So when was the first time the intro video started playing? Or in case the intro video was not present, what is the time to actually they add like a custom event when the game lobby is loaded, and we track that specific thing. So just one, I would say no, but if you need to pick one, I would go for when the game is actually loaded and when you see the let's say the game lobby.
Brilliant, thank you. Another question we've got here is sort of looking beyond some of the stuff we talked about today, perhaps. Can this be tied towards other metrics like conversion and retention of users that sign up?
Yes. So so out of the box, we track things like bounce rate, session length. On top of that, you can create your own custom custom metrics, which can link to your business metrics. So for one of the game providers, we actually tracked the amount of times they clicked on, let's say, each time when they clicked on the button to, let's say, in one of the casino games, that was each time that was tracked as a user interaction. Some of them it's like how many people sign up. So you might have some demo games and how many people actually upgrade to a full account and validate if, let's say, that conversion can be tied to performance.
Brilliant. And another question for the capabilities of the system. Is it possible to set up A/B testing with this tool?
Yes, it's very easy to set up A/B testing. So we don't do the A/B test, so you still need to decide if it's version A, B, or C. Well, so we support multivariant testing with multiple versions. So one of the things is you can create a dimension which reads, for example, if it's version A, B, or C, either based on a cookie or on a JavaScript variable, doesn't matter. And then you can, for example, look at the performance, let's say the load time of the different A/B versions. Correct. So yes, easy.
And then someone here said, let's say that we're using React. Can we still use mPulse? How will this work together?
Excellent question, and it's excellent because I forgot to mention this. So this works very well both with, so I said modern HTML5 games, so it's not just for let's say plain old HTML, CSS, JavaScript. We also support single page app frameworks. So it doesn't matter if it's React, Angular, or whatever. And then you can actually see soft navigations, hard navigations, and really track all these individual things. So both work and are fully compatible.
And can alerts be set up to trigger a webhook for tools like Slack?
Sorry, can you repeat the question, please?
Sure thing. Can alerts be set up to trigger a webhook for tools like Slack?
Yes, absolutely. So I won't show it, but you can set up multiple alerts. For example, if a certain timer exceeds a certain value over a certain time, and then you can either send an email. There is a REST, you can call a REST API of your choice, and there is a direct integration actually with Slack as well. So I have many customers each time when there is an incident, for example, the beacons drop, and that means that there is an issue with the amount of players, or the performance is increased, or the amount of bytes of a game has exceeded a certain value, then it automatically triggers an alert.
And then as a relatively swift follow-up to that one, can native apps be tracked as well for iOS and Android?
Yes, so we have an SDK which allows sending beacons. So that's one option. Either use the SDK, or we also have a REST mPulse. We also have a REST API where you can send any metrics inside the native app, which might not be network related, but maybe other performance related. You can send those via REST API to us. We collect them, and you can then consume those from within the dashboard.
Brilliant. And then we've had a follow-up question based on the mPulse question from before. Can you use mPulse and extract the data to other analytics tools in the backend using SIEM?
Using what?
SIEM?
Okay, yes. So mPulse itself, there are multiple options there. So the key thing is it's a fully cloud-based platform. So we collect all the data, so you don't have to worry about the scalability of that. Some of our customers say we do need the raw beacons, we do need the raw data. So there we can, for example, automatically export it to an S3 bucket, and then from there you can do whatever you want with that data. So we don't have, let's say, a SIEM integrator like you said. So via sending it first via S3 would be a first step. The alternative is we also have a query API, which is a REST API where you can create, let's say, custom dashboards, or if you have, if you want to show, let's say, an impulse data in an external tool, you can also query such data very easily via a REST API.
Brilliant. And how long can you go back in time to look at legacy data?
Yes, good question. It's 13 months, so a bit more than a year.
And then another question that's come in is sort of more general, I suppose, but what, from your perspective, have been some of the most significant changes made by partners as a result of this data and the services you guys are providing?
Let me actually show this. This, what you see here, is actually what you see here is the first input delay, and that tracks the delay between when the user clicks. For example, the user sees a button, clicks on play, clicks on that button, and then how long it takes for the browser to actually start working on that user request. And so if you have other JavaScript running, let's say for 200 milliseconds, and if you click, and that other JavaScript still takes 200 milliseconds, it can only start working after 200 milliseconds. So what you see here is one of the, let's say, the JavaScript performance of, let's say, after making some JavaScript loads differently based on what we detect, based on some issues we detected. And here you see that the first input delay drops from almost 1 second. Then this was then linked to a certain browser, an older browser which still had enough users, where it actually went from more than 1 second. So you click and you need to wait more than 1 second before it behaved, and then straight away dropping it towards the, let's say, 100 millisecond range, which is, and that's like for the worst users. So this is, for example, a nice nice thing with the things we can do. I don't know if that answers your question. Another example is, for example, where we spotted that certain pages or games really downloaded a huge amount of data because there was like a 5 megabyte small icon, which was like a PNG and not optimized. And although it didn't really impact the performance of the game, it did, of course, contribute to a huge amount of additional data for, let's say, people playing on mobile devices, or also on the CDN bill. If you can choose between downloading 5 megabytes or 5 kilobytes, that's of course also a difference. I don't know if that answers the question from the question asker.
I would hope so, but again, if anyone's got follow-ups, obviously do submit them in the question box. We've got a couple more questions on Impulse coming in again. In terms of gaming customers who are using Impulse, what's the general feedback from them at this point?
General feedback is very positive. So we did for, let's say, a very large European customer, we did a POC last year, because although, let's say, Impulse is initially designed more for, let's say, tracking websites, so they had, let's say, their valid questions like, hey, how can we build this into, let's say, our gaming platform? We have thousands of games. How can we find a way to let's say, to make it scalable and not set up custom timers for every single game? Doesn't it make the game slower? And that was also a question. Doesn't it break things? So there we did some, let's say, some extensive POC, but all was, let's say, very positive, mainly on the JavaScript performance and these perceived metrics, because insights on the download times, I guess everybody has, but that's not necessarily a direct link with let's say, the end user perceived performance. So the JavaScript and the perceived performance, plus then having that common language, that was also very positive, having that common language between the business and then pure, let's say, technical. Should we work on a additional feature on that game? Should we prioritize on maybe 2 or 3 smaller bugs? Or should we focus on performance? And typically, so far, it was always like at the end, performance was moved to the next sprint, or was moved to the next release because, oh yeah, are we sure that performance matters? Are we sure that performance matters? Now with this data, you actually know that performance matters or not for some games.
And then obviously we're working in a hyper-competitive space. Things are so changeable in this industry. How can or will your product continue to adapt and develop in the midst of this change?
Yes, Amples is, if you look at how Amples changed in the last 3 years, we are constantly adding new metrics. Browsers get new capabilities. For example, this first input delay you're actually seeing here, that was added, let's say that was added last year because newer browsers proposed that. So we are continuously adding more features and adding new capabilities. For example, the single page apps, of course, they're not really that new, but tracking that performance in a good way is in the end not easy. But we are really, I would say, we are on top of things to make sure that with the latest things we are up to date. For example, one of the things we are working on now with service workers that has some benefits, could also have some downsides. So we are working on adding some custom timers to also track the startup performance of a service worker, for example.
Exciting times ahead then. We're approaching the end of our time that we have for today, but I'd like to thank you again, Tim, for joining us and sharing your insights and giving us a bit of a demonstration today. To our audience, the webinar has been recorded and will be available to listen to on demand shortly, or to rewatch and share with your colleagues. If you do have any further questions, we are more than happy to put you in touch. Otherwise, we'll be seeing you all soon. Thank you very much.
Thank you.